And now I would like to show you our new concept and some results from the mission of 𝗖𝗁. Well, what is 27G technology? Basically, we are an R&D company with the aim to help space missions with new ideas. Actually, we are developing many solutions that could help small-sat missions. That's why I received this invitation from Tom and 𝗨𝘀, and thank you for that. Well, we developing unique devices for dosimetry and radiation sensing, and this could be particularly useful for satellite and remote applications. And I will show you this one. I will talk a little bit about this tiny module. You can see it in my hand. It's that small. In the next slide, you can see that this one is actually smaller than a €1 coin. It's our new product that will be introduced to the market at the end of this year. This one is currently the world's smallest dosimeter instrument. You know some details here. It's a really tiny electrical chip that you can include in your pocket cube or small satellite PCB. It's easy to connect this one via UART or SPI bus and communicate with this one. And the operation principle is simple, and it's similar to the GPS modules, but instead of position data, this small instrument can give you information about the local radiation environment of the instrument. We are using fully semiconductor-based technology, so there are no GM tubes or electromechanical parts. Therefore, it's a really reliable design. It can sense ionizing radiation dose from 1 rad to up to even 100K rad. It have a really low power consumption under 10 microwatt standby. This one means around 2 microamps from a standard 3.3 volt satellite bus voltage. And one measurement takes about 300 milliseconds, so it's pretty fast. And for this, during the measurement, it uses only a few milliamps. So it's a really power-saving little instrument. And our aim is to develop this solution to be as widely usable as possible, especially for the space industry and for space missions. We integrated other useful functions such as configurable alarms, precision clock oscillator, temperature sensor, and so on. So with this tiny module, it could be really useful for satellite missions, scientific experiments, for the nuclear industry, aviation safety, or personal dosimetry purposes. But of course, we are here at this conference due to the space-related missions. So I would like to talk a little bit about the benefits of this new idea to build like this small instrument. So why is this useful for satellite missions? As you may know, there is a strong intensity of ionizing radiation in space, consisting essentially of particles emitted by the sun and galactic cosmic radiation. Most of this radiation is proton and alpha radiation, but it also includes electron, gamma, and X-ray and neutron radiation. And life in Earth is protected by the magnetic field of our planet. But our space devices far from the surface of Earth is not well protected against this radiation. And this radiation could damage your electronic equipment. And after time, it can cause failures for satellites and electrical circuits. So with this tiny module, you will see the results of 𝗖𝗁 later. You can measure and monitor the total ionizing radiation dose during your space mission. That could be useful. For example, you can measure and examine the effects of the South Atlantic anomaly or other effects that reach your satellite. For example, a solar flare, and so on and so on. So it's you will see that it's a really useful little instrument. A little bit about our history. My colleague Levente Dudás hold his presentation about the SMOG and ATL satellites. 𝗖𝗁 is actually the second satellite of Hungary. We started to build this small 1PQ pocket cube satellite back in 2014 in the frame of the Technical University of Budapest. And we wanted to use, actually this is really a small satellite. You obviously know how small 1PQ is, but I have a model here in my hand, and we tried to use as much the available space as we could to include as much sensors and scientific experiments as possible. And it was a part of this mission to build the prototype of this total ionizing radiation sensor. And we started, actually, the 𝗖𝗁 was launched at the end of the previous year. And it was a really successful mission. And two pieces of this experimental instrument were included in this small satellite. And I would like to show you, yeah, actually, this is my favorite picture of the launch event. I had to include this in my presentation. I really like it. So these are the first field results I wanted to show you. So about the capabilities of this type of instrument, you can see these curves. The instruments are continuously worked during the mission of 𝗖𝗁 and measure the radiation dose on board. And you can see that they measured around 12 rad of total ionizing radiation dose. The blue dots shows the TID1, the results of TID1, and the green one shows the results of TID2. These are two completely separated individual instruments. And you can see I included some conclusions here at the slide, that the correlation is quite high between the two instruments. And the results are really similar to the doses measurable at the ISS. So from the experiment point of view, it's a really successful. It was a really successful experiment to launch these small instruments with 𝗁𝗁. Even small radiation is detectable for these instruments because I designed this instrument to be able to measure radiation doses up to 40,000 rads. And actually, you can see that the overall measured dose was only 12. So the usage of this instrument is less than 1%. And that's due to the really low Earth orbit of 𝗁𝗁. And you can see that the saturating slope of this curve, so the radiation dose is continuously decreased during the mission, and that's due to the protection of the magnetic field as the altitude of the satellite was decreased. And yeah, and one other conclusion that TID1 was located at the center of the SAT, while TID2 was closer to the outside. And you can see that the second instrument measured a little bit higher radiation. So I have a theory that this is caused by the higher dose due to the so TID1 was better protected by the satellite itself. And of course, 𝗁𝗁 will confirm this theory, hopefully. A little bit about our history. So the team of 27G Technology consists of some development engineers of this SMOG satellite development team. After the successful launch of 𝗁𝗁 and ATL1, we wanted to continue some of the developments. You know, we are developer minds. We are open for new developments, and we like to do what we do. So we wanted to use our experiences and try to create something new further than 𝗁𝗁. So we started this startup, and it's already it started only in this year, February, but so far we have quite good results. This startup is actually at the this year's top list of the startup top list of the European Space Agency. We received already a wide international interest, so hopefully we could help in a lot of space missions in the future. Okay, our first product, the TIDS, this one that I showed you. Actually, we are just before the product release. We doing the testing and certification currently. The last tests are running, and hopefully we will have the release of this small instrument, and you can include this in your designs at the future space missions. So basically, yes, basically this was my short presentation about this this concept. If you have any questions, unfortunately, I cannot see the questions from YouTube, but here is my email address. You can send us your questions, and we are happy to answer and contact you. Yeah, 𝗁𝗁 will be launched at Q1 next year, and we will have hopefully a new successful Pocket Cube mission. So thank you again for 𝗖𝗀 for the invitation, and thank you for organizing this event.